Hello class, this is Mr. Hunter and this is your video notes on projectile motion notes part 1 today, and we'll probably finish part 2 at a later time. So today we're going to learn about motion on the X and the Y axis. So far, as I stated in class, we've only been dealing with motion on one axis. So the x-axis, we'll be dealing with whether an object accelerates or if it's moving at constant velocity, and the positive and y direction. Or we've only been dealing with motion on the y-axis. So when I throw a ball up and down or when I drop a ball, using the acceleration due to gravity, I can figure out certain variables. So in two-dimensional motion, we now deal with displacement, velocity, and acceleration in the x and the y directions. Note, the x and y directions are independent of each other, meaning they don't affect each other. So for example, like the crude example that I used in class, x's and y's are like Bloods and Crips. They don't mix. Because when you're calculating something on the x-axis, you only use what you know on the x-axis. If you're calculating something in the y-axis, you only use the variables you know for the y-axis. For example, you should never ever be using the acceleration due to gravity when you have a car traveling down a street or a kid is pushing someone down the street or yada, yada, yada. If it's on the x-axis, you don't have that acceleration unless they tell you or you calculated it. So for the vertical, the y direction variables are height, which is the displacement in the y, how high the object goes, the acceleration due to gravity, which is 9.8 meters per second squared, and depending if we say up is positive, then it becomes negative, or if we say down is positive, it becomes positive. We have time and initial velocity in the y. Those are the y variables or the vertical direction. Now, we use time in the vertical direction because that dictates the acceleration due to gravity dictates how long it will take for an object to hit the ground. For example, in class today, I shot an object out to the right and dropped it at the same time, and you guys in class should have discovered when they hit the ground, which I'm not telling you the answer because one class didn't get to do that yet. Horizontal is the x direction. It's the how far the object travels, so it's the displacement in the x. And then you have the initial velocity in the x. You also have something that I didn't write here, which is acceleration in the x. And I'm going to tell you now we are ignoring friction. So since we are ignoring friction, acceleration in the x is 0 meters per second squared because there's nothing causing the ball to slow down or speed up in the x direction. When I launch an object, I'm ignoring air friction, so air friction technically doesn't slow it down, and I'm not behind the ball continuing to push it forward. So we're going to be in the leftmost column. Now, I will have this capture sheet for you in class tomorrow if you're taking these notes on Monday as soon as they are released, or you can just write them in the notebook. Gravity is a force. We already discussed this in previous notes, and a force is a push or pull. The thing about forces is it causes acceleration. Think about it. If I keep constantly pushing something, it's going to get faster and faster and faster. So forces cause an acceleration. And I also said that in the previous notes. So, warning, important information. Because gravity is a force, it pulls on an object and causes it to accelerate. So the acceleration due to gravity is 9.8 meters per second squared. And remember, this is the acceleration caused by the force of gravity. In the future, aka next unit, you're going to have to figure out the force due to gravity, and you have to make sure you distinguish between the acceleration and the force. So this leads us to the equations I've already introduced you to. These equations you can use under constant acceleration, and gravity is always a constant acceleration situation because the only way I can change a gravity is if I change the mass of the Earth. And the only way I could do that is by blowing up part of the Earth, which would make a lot of people unhappy. So we have our final velocity equals initial velocity plus acceleration times time. or our final velocity squared equals our initial velocity squared plus 2 times acceleration times distance, or distance equals initial velocity times time plus acceleration times time squared divided by 2. So in this case, the best way for me to really teach you is to give you examples and walk you through the examples. So make sure if you get stuck or if I'm going too fast, just slow down the video and replay it. So in this example, I'm going to toss a ball into the air and analyze its motion. We're going to give the ball an initial velocity of 30 meters per second in the vertical direction. Now, notice that I said that I'm going to give it an initial velocity of 30 meters per second, and I'm throwing the ball up, which means if I'm throwing the ball up has to be positive, down has to be negative. So up is positive, down has to be negative in this case. And remember, positive and negative numbers just means our direction. It's impossible to truly have a negative 30 meters per second, but that just means I'm heading in the opposite direction. So let's use some math. So let's calculate the velocity after each second. In this case, the up direction is positive. So let's list the variables that we know. So now I'm going to do LEPA. I know that my initial velocity is 30 meters per second. My time it's going to take is t equals 1 second because I want to find the final velocity after 1 second, so VF equals question mark. And finally, I know that the acceleration due to gravity, remember I said up is positive, down has to be negative. For the sake of the math, because I don't have a calculator with me, I'm just going to round up, and I'm going to make my acceleration 10 meters per second squared. So that's my LEPA. I'm looking for the final velocity after 1 second. So then my E is, let's look at these three equations, so let's practice. What of these three equations do I have initial velocity, final velocity, acceleration, and time? And if I look, it's that one. Don't have distance, can't use that equation. So that means the second and third equation are out. So that's how you use LEPA. So then VF equals VI plus AT. So my final velocity is going to equal my initial velocity, which is 30, plus negative 10 times 1 second. So I get VF equal to 30 minus 10 equals 20 meters per second, and that's my answer. Now, so I come back up here and I look and I'm like, okay, cool, 20 meters per second. So for the sake of time, I'm not going to do it, but I could do this same calculation for every single second. I could say if my initial velocity is 30, time 2 seconds, what's my velocity, and my final velocity with an acceleration of negative 10, and then I'm going to calculate an answer of 10 meters per second. I can do the same thing for 3 seconds, and I'll get at this point that it's 0 meters per second. So when I launch this ball straight up in the air, once it hits 3 seconds, the velocity in the y direction equals 0, which means it stops because the gravity, as you could tell, is pulling it down. So then I can go and plug in 4 seconds in the equation, and I'll get a value of negative 10 meters per second. Well, what does that mean? It means it's coming back towards my hand, and after 4 seconds, it's moving at negative 10 meters per second. So it's moving back towards me, and that's what that negative means. If I plug in 5 seconds, I'll get negative 20 meters per second. And then at 6 seconds, it reaches back to my hand, and it's moving at the same speed it was, just opposite direction. And that's a critical feature that we can use in future calculations. You can always say that your final velocity in the y is going to equal your negative of your initial velocity in the y. Because look, we started with 30 meters per second, and the time it got back to my hand, or the same point it left, it was moving at negative its value. We can use that trick in the future. So go ahead and flip over to the back, and we're going to be looking in the first column. If you weren't able to fit that's why I put example 1, tossing a ball up. That's where I am continuing those notes. Okay, so I want you to scroll to the bottom And in this part, we're going to look at example, and I gave you this example in class, and this will bring us to the end of these notes. A seagull flying in the air drops a clam. It takes 3 seconds to hit the ground. How high in the air is the seagull? And this is a typical Regents problem that they'll throw at you. So they want to know the distance in the y direction. Now I want you to notice that now instead of just writing my distance, I'm actually writing what axis it's on. Because remember, X's and Y's are like Bloods and Crips. They don't mix. And I say that, and I know it's a crude example, but you'll remember it because that's how I'm telling you it. So we're looking for our distance in the Y. We want to know how high the seagull is. Excuse me. We know that the time it takes to drop is 3 seconds, and I am on Earth, so my acceleration due to gravity, and I'm just going to average here, I mean round up, not average, to 10 meters per second squared. Now in this case, I'm calling down positive because I don't throw anything up, and so I might as well make my calculations easy and just say down is positive. Now there's something you also know. You know that the clam is dropped, which means my initial velocity in the y direction is 0 meters per second. Just like when you drop that golf ball in your acceleration lab, or for those of you who do-it-yourself motion lab, you guys dropped objects. Okay, so now go look what equation has distance, time, acceleration, and initial velocity. Your answer should be dy equals vi y times time plus ay t squared divided by 2. Notice I'm putting all of the x's and the y's on there. And notice, like I said, x and y's don't mix, so I don't have any x values in here. So now I just plug in and solve. I have dy equals 0 times 3 plus 10 divided by 2 times 3 squared. And when I do that math, I get dy equals 0 plus 10 times divided by 2 is 5. So I have 5 times 9 equals 45 meters. So that seagull is 45 meters above the ground, and that is essentially still one-dimensional motion, but in the y direction. I'll see you in class with this.